March 15th, 1968, Mexico City. Carlos Gonzalez wiped the grease from his hands and stared at the Volkswagen Beetle engine on his workbench. The mechanic from Puebla had been fixing these air-cooled flat fours for 8 years at the dealership, but this time was different. He wasn't fixing anything. He was about to prove that every German engineer who designed this motor had been wrong about its limits. The factory manual sat open on the bench, its pages marked with thumbprints and oil stains. Page 47 claimed the 1600cc engine could produce 50 horsepower reliably. Any more displacement, any more power, and the air cooling system would fail. The pistons would seize. The heads would crack. Volkswagen's engineers in Wolfsburg had been adamant about these limitations since Ferdinand Porsche first designed the engine in 1938. Carlos thought they were full of it. Outside the garage, Mexico City's altitude meant every engine was already fighting for oxygen at 7,350 feet above sea level. The thin air that made German engineers nervous had taught Carlos something different. These engines were tougher than anyone realized. He'd seen them survive abuse that should have killed them. Taxis running 20 hours straight in 100-degree heat, delivery trucks overloaded by 3 times their rating, amateur racers bouncing off the rev limiter every weekend at the local strip. The Beetle engine didn't die easy. Carlos picked up the crankshaft he'd been modifying for 3 months. A friend who worked at a machine shop near the airport had helped him grind it to specifications that existed nowhere in any manual. The stroke was increased from 69 millimeters to 84 millimeters. Combined with larger cylinders he'd fabricated himself, this would push displacement from 1600cc to 2300cc. According to Volkswagen, this engine should explode the first time he started it. The idea had come to him 6 months earlier while watching American muscle cars at the Autodromo Hermanos Rodriguez. A Chevrolet Camaro with a 396 cubic inch engine had destroyed everything on the track, including several expensive European sports cars. But what stuck with Carlos wasn't the Camaro's victory. It was how much that massive V8 weighed, nearly 600 pounds. The Volkswagen Flat 4 weighed 150 pounds. If he could triple its power output while keeping that weight advantage, he'd have something special. His boss, Hernando Villanueva, thought he was wasting his time. The dealership owner had caught Carlos working on his project after hours and laughed. "You want to turn a people's car into a race car? These engines are for going to market, not breaking records. Volkswagen spent millions designing these limits. You think you know better than German engineers?" Carlos did think he knew better, at least about this. The Germans had designed the engine for European conditions: sea-level altitude, moderate temperatures, smooth autobahns. Mexico was different. The engines here had to work harder just to maintain normal operation. That constant stress had taught him where the real weak points were, and more importantly, where the hidden strengths lay. The cylinder heads were his first breakthrough. The stock heads used small valves that restricted airflow. Carlos had studied fluid dynamics at night school before dropping out to support his family. He understood that doubling the engine's displacement meant nothing if you couldn't feed it enough air. Using a die grinder and patience, he enlarged the ports and fitted valves from a Porsche 356 he'd found in a junkyard. The Porsche was just a fancy Beetle anyway, its engine sharing the same basic architecture. Installing the bigger valves required precise work. One slip, and the whole head would be ruined. Carlos worked by feel as much as measurement, his fingers detecting imperfections smaller than a human hair. His father had been a gunsmith in the Revolution, fixing rifles for Pancho Villa's army. Carlos inherited those hands, steady, patient, precise. Where his father had kept men alive by maintaining their weapons, Carlos was trying to bring an engine to life beyond its intended limits. The camshaft was next. The stock cam was designed for fuel economy and smooth idle. Carlos needed something that would keep the valves open longer, allowing more air and fuel into the cylinders. He found a shop that specialized in agricultural equipment and convinced them to grind him a custom cam based on his specifications. The profile was aggressive, so aggressive that the engine would barely idle. But at high RPM, it would sing. By April, he had assembled his first prototype. The engine sat on a test stand in the corner of the garage, looking almost identical to a stock motor, except for the custom exhaust headers snaking away from each cylinder. Carlos had fabricated these himself, calculating the optimal length for scavenging exhaust gases. Every improvement built on the next. The bigger displacement needed more air, which required bigger valves, which demanded a wilder cam, which necessitated better exhaust flow. The first start was scheduled for a Sunday morning when the dealership was closed. Carlos arrived at dawn, bringing his nephew Miguel as a witness. Miguel was 17 and obsessed with racing. He'd been helping Carlos on weekends, learning that building engines required more math than muscle. Carlos poured oil into the crankcase, checking the level 3 times. He'd modified the oil system too, adding an extra cooler and increasing the pump pressure. The stock system pumped 3 quarts of oil. His pushed 5 quarts at nearly double the pressure. Heat was the enemy of air-cooled engines, and oil was the second line of defense after airflow. He connected the battery and fuel line. The moment had a weight to it that made his chest tight. 3 months of work, hundreds of hours, most of his savings invested in machine work and parts. If the engine destroyed itself, he'd have nothing to show but scrap metal and debt. The starter motor engaged with a whir. The engine turned over once, twice, then caught with a bark that rattled the windows. The idle was rough, hunting between 800 and 1200 RPM as the wild cam profile fought against low-speed operation, but it was running. The gauges showed oil pressure at 60 psi, perfect, temperature climbing but stable. Carlos let it warm up for 5 minutes, then slowly increased the throttle. At 2000 RPM, the roughness disappeared. At 3000 RPM, the engine found its voice, a deep, angry sound completely unlike the sewing machine noise of a stock Beetle. At 4000 RPM, Miguel started backing away from the test stand. The whole engine was shaking against its mounts, but the gauges stayed steady. Oil pressure held. Temperature stabilized at 180 degrees Fahrenheit. He pushed it to 5000 RPM and held it there for 30 seconds. Stock engines would be screaming for mercy at this speed. His 2300cc motor sounded like it was just waking up. At 6000 RPM, he finally backed off. The engine returned to its lumpy, idle, oil pressure still perfect. No smoke, no rattles, no signs of distress. "Holy Mother of God," Miguel whispered. "How much power do you think it makes?" Carlos had done the calculations. Based on his improvements and assuming 85% volumetric efficiency, the engine should produce between 150 and 180 horsepower, triple the stock output. But calculations were just theory. He needed real-world testing. The next step was finding a car to put it in. Carlos owned a 1965 Beetle he'd bought, wrecked and rebuilt. It was primer gray and looked like hell, which was perfect. Nobody would suspect what was under the engine cover. He spent the next weekend installing the motor, reinforcing the transmission mounts, and adding wider rear tires that would fit under the stock fenders if he rolled them flat with a baseball bat. The first test drive was at midnight on a deserted industrial road near the airport. Carlos eased out the clutch, and the Beetle lurched forward with violence. The stock clutch couldn't handle the torque. He limped home and spent another week installing a Kennedy Engineering clutch designed for drag racing, imported from California at considerable expense. The second test drive revealed another problem. The stock carburetor couldn't feed enough fuel. The engine would pull hard to 4000 RPM, then go flat. Carlos needed Weber carburetors, expensive Italian units that cost more than most Mexicans made in 2 months. He sold his motorcycle and his watch to buy a pair of used 40mm Webers from a racer who'd crashed his Porsche. By June, the car was finally sorted. Carlos had told no one except Miguel about his project. The Mexico City racing scene was small and gossipy. He wanted to arrive with proof, not promises. The local drag strip operated on Sunday mornings before the heat made the asphalt too soft. Admission was 20 pesos to race, 50 pesos to watch. That first Sunday, Carlos arrived late deliberately, signing up for the last round of qualifying. The other racers barely noticed the primer gray Beetle joining the staging lanes. Most were focused on a candy apple red Mustang that had been dominating the local scene, running consistent 14-second quarter miles. When Carlos pulled to the starting line, the track official laughed. "You sure you're in the right class, friend? This is for cars that can break 15 seconds. Carlos just nodded and waited for the green light. When it came, he dumped the clutch at 4,000 RPM. The Beetle left the line so hard the front wheels lifted 6 inches off the ground. The crowd, what little was paying attention, went silent. The car shot down the quarter mile like it was being pulled by a cable, the engine shrieking at 7,000 RPM in third gear before Carlos grabbed fourth. The timing board showed 12.8 seconds at 108 miles per hour. The Mustang owner, a wealthy kid named Ricardo, whose father owned several hotels, immediately accused Carlos of cheating. "No Beetle can run 12s. You've got nitrous or something." Carlos popped the engine cover. The motor looked almost stock except for the exhaust and carburetors. Ricardo insisted on seeing underneath, convinced there were hidden bottles of nitrous oxide. There was nothing but a stock fuel tank and spare tire. Word spread through Mexico City's racing community within days. A mechanic from a Volkswagen dealership had built a naturally aspirated Beetle that could outrun American muscle cars. It seemed impossible. Volkswagen themselves said their engines couldn't reliably exceed 1,800 cc. This guy claimed his was 2,300 cc and still air-cooled. The challenges came immediately. Carlos spent every Sunday at the drag strip that summer, racing for money now. The Beetle never lost to another 4-cylinder car and beat most 6-cylinders. The only cars consistently faster were big block V8s with twice the displacement and 4 times the weight. But racing exposed problems. The engine consumed itself slowly. After 20 passes, the valves needed adjustment. After 40 passes, the pistons showed scuffing. The bearing clearances he'd carefully set were opening up. The engine was making power that the basic architecture couldn't sustain indefinitely. Carlos spent his winnings on better parts. Forged pistons from Germany designed for Porsche racing engines. Chrome moly push rods that wouldn't flex under the pressure. A forged crankshaft that cost more than he made in 3 months. Each improvement extended the engine's life and added power. By September, his second-generation engine was producing 200 horsepower on a dynamometer at the Technical University. A professor of engineering who'd heard about the Beetle invited Carlos to test it on their equipment. The number seemed impossible. 4 times the stock output from an air-cooled engine that Volkswagen claimed couldn't handle any significant modifications. The professor, Dr. Eduardo Ramirez, studied the readouts with disbelief. "This shouldn't work. The cooling system can't possibly dissipate this much heat. You're generating nearly 70,000 BTUs per hour. The stock cooling system is designed for maybe 25,000. Carlos explained his modifications. He'd increased the fin area on the cylinders by 30%. The cooling fan was from a Porsche 911, spinning faster than stock. He'd added oil cooling capacity and ceramic coating on the piston crowns to reflect heat. Every modification worked together to manage the thermal load. "You've essentially redesigned the engine while keeping its basic architecture," Dr. Ramirez said. "Volkswagen never pushed these boundaries because they prioritized reliability over performance. You've proven the design has far more potential than they claimed." The doctor's validation meant everything to Carlos. He wasn't just some mechanic hot-rodding cars. He'd done real engineering, even without a degree. His father had always said that wisdom came from working with your hands, not from books. But Carlos had used both, practical experience combined with theoretical knowledge he'd gathered from textbooks and racing magazines. The racing victories continued through the fall. Carlos built engines for other racers now, charging enough to quit his dealership job. Each engine was slightly different, tailored to the owner's needs. Some wanted maximum power for drag racing. Others needed broader torque for road racing at the autodrome. He kept refining his designs, finding another 5 horsepower here, another 3 pound-feet of torque there. His notebook filled with combinations that worked and ones that didn't. A 2400cc version he built seized after 2 runs, the cooling system finally overwhelmed. A 2200cc engine with milder cams proved ideal for street driving while still making 160 horsepower. He learned that zinc additives in the oil prevented cam wear. That deck height affected compression more than chamber size. That port matching mattered more than port size. In November, Volkswagen sent 2 engineers from their Mexico plant to investigate. They'd heard rumors about a mechanic building impossible engines and wanted to see for themselves. Carlos was suspicious, but agreed to show them his work. The Germans took photographs and measurements, speaking rapidly in their language while examining his modifications. "This is very impressive," one finally said in Spanish, "but surely the longevity is compromised. How many kilometers before rebuild?" Carlos showed them his personal Beetle's odometer, 15,000 kilometers since the engine was built, still running strong, still making power. He'd proven these engines could be both powerful and reasonably reliable if built correctly. The Germans left without saying much, but a month later, Carlos received a letter from Volkswagen offering him a job at their Puebla plant. They wanted him to work on a performance version of the Beetle for the Mexican market. The salary was 3 times what he'd made at the dealership. Carlos turned them down. He was making more than that building engines for racers, and he was his own boss. His nephew Miguel had become his apprentice, learning the careful work of porting heads and clearancing crankshafts. Together, they could build an engine in a week. The waiting list stretched 2 months. Racers from Texas and California were calling, wanting to buy engines or learn his secrets. Carlos started selling what he called stroker kits, the modified crankshaft, pistons, and cylinders needed to increase displacement. The kits came with detailed instructions he'd typed on his mother's typewriter, complete with hand-drawn diagrams showing every measurement and clearance. A racer with basic mechanical skills could install the kit and double their engine's power. The first customer outside Mexico was a Texan named Jim Bradley, who'd driven 16 hours to pick up a kit. Jim owned a speed shop in Austin and had heard about the Mexican Beetles running 12-second quarters. He didn't believe it until Carlos took him for a ride in his personal car. The acceleration pressed Jim into the seat like a rocket sled. The speedometer, which only went to 90 miles per hour, was buried before they hit 4th gear. "I've built small block Chevys that don't pull this hard," Jim said, breathing heavily after the run. "And this thing weighs nothing. It's like a motorcycle with 4 wheels." Jim became Carlos's American distributor, selling stroker kits throughout Texas and California. The VW racing community in America was small but passionate. They'd been trying to make Beetles fast for years, with limited success. Carlos's kits changed everything. Suddenly, Beetles were competitive with muscle cars at a fraction of the cost. The money was good, but Carlos cared more about the vindication. Every engine that survived, every race won, proved his point. Volkswagen had been too conservative, too focused on the average consumer who would never push their engine past 3,000 RPM. They'd ignored the potential that lived in their own design. By early 1969, Carlos was building complete engines for export. He'd hired 2 more mechanics and moved to a larger shop near the airport. The engines were crated and shipped to America, where they sold for 5 times what a stock engine cost. Racers didn't care about the price. They wanted the power. The evolution continued. Carlos developed aluminum cylinder heads that saved 20 pounds while improving cooling. He experimented with fuel injection from a Bosch system meant for Mercedes, adapting it to work with his wild cams. He tried turbocharging but found the heat management impossible with air cooling. Every failure taught him something new. His engines powered more than just drag cars now. A road racer named Paulo used a 2100cc version to win the Mexican Sports Car Championship, beating Porsches and Alphas on tight circuits where power-to-weight ratio mattered more than absolute speed. A hill climb specialist in Oaxaca set records with a 2300cc engine in a stripped Beetle that weighed 200 pounds. The combination of lightweight and big power proved unbeatable on twisty mountain roads. The Technical University invited Carlos to give a lecture about his work. He stood in front of engineering students, most from wealthy families, and explained how he'd developed his modifications without formal training. The students took notes as he wrote equations on the blackboard showing the relationship between bore, stroke, and piston speed, how rod ratio affected torque curves, why valve timing mattered more than valve size. One student asked why Volkswagen didn't build these engines themselves. Because they're a business, Carlos answered. They need to sell 1 million engines that last 100,000 kilometers with minimal maintenance. I build 50 engines a year that need attention every 5,000 kilometers. We're solving different problems. But privately, Carlos believed it was more than that. Large companies became prisoners of their own assumptions. Volkswagen had decided in 1938 what their engine could and couldn't do. That decision had become gospel, repeated in every manual and technical bulletin. It took someone outside the system to question those limits. The success brought problems. Other shops started copying his designs, building inferior engines that failed and damaged his reputation. A customer in Arizona blew up an engine built by someone claiming to use Carlos's specifications. The resulting lawsuit cost Carlos thousands of dollars in legal fees before he could prove the engine wasn't his. He started stamping serial numbers on every component, creating a paper trail that authenticated genuine parts. He published a newsletter for customers, sharing technical tips and warning about counterfeit parts. Building a reputation had taken years. Protecting it required constant vigilance. Miguel had become a talented engine builder in his own right. At 20, he could port ahead as well as Carlos. He had ideas too, like offset, grinding the crankshaft journals to increase stroke without changing the main bearing size. The modification added another 50 cc of displacement and 10 horsepower. Carlos was proud. The knowledge would continue. In March 1970, exactly 2 years after building his first stroker engine, Carlos received unexpected visitors. 3 men from Porsche arrived at his shop. Unlike the Volkswagen engineers, they weren't skeptical. They knew about his work and respected it. Porsche was developing their own air-cooled racing engines and wanted to understand his cooling solutions. Carlos spent a day with them, sharing techniques he'd developed through trial and error. How coating the exhaust ports with ceramic prevented heat soak into the heads. How varying the fin spacing on cylinders improved airflow. How oil squirters aimed at the piston undersides could drop temperatures by 50 degrees. The Porsche engineers took notes and photographs. Before leaving, one said, "You should have been born in Stuttgart. You would have been one of our best." Carlos smiled, but said nothing. He'd been born exactly where he needed to be. In Germany, he would have been constrained by corporate hierarchy and established thinking. In Mexico, poverty and necessity had forced him to innovate. Every limitation had become a teacher. The racing continued through the early 70s. Carlos's engines dominated Mexican drag racing so thoroughly that some tracks created separate classes for VW engines versus everything else. It was the only way to keep racing competitive. A stock Camaro with 350 cubic inches had no chance against a 2300cc Beetle that weighed half as much. But the most satisfying victories came at the road course. Road racing required the engine to survive 20 minutes of maximum stress, not just 13 seconds. Heat management became critical. Oil temperature could reach 280 degrees Fahrenheit. Cylinder head temperatures approached 400 degrees. Every weakness revealed itself on the road course. Carlos developed dry sump oil systems that prevented starvation during hard cornering. He added oil coolers in the front bumper with electric fans for additional cooling. He experimented with different compression ratios for Mexico City's altitude versus sea-level tracks. Each track required different gearing, different carburetor jetting, different ignition timing. A customer from California commissioned the ultimate engine. Cost was no object, just maximum power. Carlos spent 6 months on it, using every trick he'd learned. Nikasil-coated cylinders from Germany, titanium connecting rods that cost more than most complete engines, heads so extensively modified they bore no resemblance to stock parts. The engine produced 245 horsepower at 8,200 RPM on the dyno. It was too much. The test engine lasted exactly 4 minutes at full power before the number 3 exhaust valve broke, sending fragments through the engine. The autopsy revealed the valve guide had seized from heat. Even with all his cooling modifications, 245 horsepower exceeded what air cooling could handle. Carlos rebuilt it with lower compression and milder cams, settling for 220 horsepower. This version survived repeated dyno pulls and powered the customer's Beetle to multiple race wins. But the lesson was clear: there were limits, even if they were far beyond what Volkswagen claimed. By 1975, Carlos employed 8 people and had built over 400 engines. His designs had spread throughout North America's VW racing community. Magazines featured his work. He received letters from racers in Germany, Japan, and Australia wanting to buy engines. But changes were coming. Emissions regulations were tightening. Volkswagen was developing water-cooled engines that would eventually replace the air-cooled. Design. The era of simple, modifiable engines was ending. Carlos could see the future: computers controlling fuel injection, catalytic converters restricting exhaust flow, lawyers and regulations making modifications illegal. He adapted by focusing on vintage racing, where older cars competed in classes based on period modifications. His engines were perfect for this growing market. He also developed street engines that made modest power increases while remaining emissions legal. A mild 1835cc engine with stock-appearing exhaust could make 75 horsepower and pass any inspection. One of his greatest satisfactions came in 1976 when a customer won the La Carrera Panamericana road race using one of his engines. The race covered 2,000 miles across Mexico in stages. The Beetle competed against purpose-built race cars with huge budgets and factory support. The little car finished 3rd overall, its 2100cc engine never missing a beat, despite temperatures reaching 110 degrees in the desert sections. After the race, Carlos examined the engine. The pistons showed normal wear. The bearings were still within specification. The valve seats hadn't receded. After 2,000 miles of racing, the engine could have gone another 10,000 miles on the street. It validated everything he'd worked toward. Power and reliability weren't mutually exclusive if you understood the engineering. His influence extended beyond just engine building. Young mechanics came to learn, not just from Mexico, but from around the world. He taught them that engineering wasn't about following rules, but understanding principles. A specification in a manual was just someone's decision, not a law of physics. Question everything, test everything, prove everything. One apprentice, a young woman named Sophia, whose father owned a taxi company, showed exceptional talent. She could hear problems others missed, a bearing starting to fail, a valve not seating properly. Carlos taught her everything, ignoring the older mechanics who grumbled about women in the shop. Sophia would later open her own performance shop in Mexico City, becoming one of the country's most respected engine builders. The business evolved with the times. As original Beetle production ended in most countries, Carlos focused on restoration and preservation. His engines powered vintage race cars worth hundreds of thousands of dollars. Collectors wanted period-correct modifications, engines that looked stock but performed like his racing motors. He could build a 2300cc engine that appeared completely original, except to an expert eye. Technology helped too. Computer modeling let him test designs without building them. CNC machining produced parts with tolerances he could never achieve by hand. Electronic fuel injection finally solved the carburetor tuning issues that had plagued high-altitude racing. But the fundamental knowledge came from those early years of trial and error, of pushing boundaries because no one said he couldn't. In 1980, Volkswagen Mexico contacted him again. They were ending Beetle production for the Mexican market and wanted to produce a special edition. Would he consult on a factory performance version? This time, Carlos agreed. The Super Beetle GT featured a mild version of his modifications, 1835cc, dual carburetors, 90 horsepower. It was a far cry from his race engines, but it proved Volkswagen finally acknowledged what he'd known all along. Their engines had untapped potential. The project led to other consulting work. Porsche hired him to help develop air cooling systems for their turbocharged race engines. A Japanese company licensed his cylinder head designs for motorcycle engines. His innovations, born from necessity in a Mexico City garage, influenced engine development worldwide. But Carlos never forgot his roots. He still built engines by hand for special customers. He still spent Sundays at the drag strip, now watching his engines compete rather than driving them himself. The speeds had increased dramatically. His latest 2400cc engines powered Beetles to 11-second quarters at over 120 miles per hour. One evening in 1982, Carlos was working late when Miguel brought his son to the shop. The boy was 10, the same age Miguel had been when he first started helping. Carlos watched Miguel teaching the boy to read a micrometer, passing on knowledge that had traveled from Carlos's father through Carlos to Miguel, and now to the next generation. That continuity mattered more than any racing victory. Knowledge wasn't meant to be hoarded, but shared. Every engine builder who learned from Carlos would teach others. The modifications would evolve, improve, spread. Long after the last air-cooled Volkswagen stopped running, the knowledge of how to make them powerful would persist. A writer from Hot Rod magazine visited in 1983, wanting to document Carlos's contributions to performance engine building. The journalist, accustomed to Detroit V8s and corporate racing programs, was amazed by what one mechanic had accomplished with minimal resources. The article, titled "The Mexican Magician," introduced Carlos to a wider audience, though he disliked the nickname. He wasn't performing magic. He was doing engineering. The article brought more attention than Carlos wanted. Volkswagen historians contacted him, wanting to preserve his early engines for museums. Universities requested his papers and notebooks for their archives. He obliged when possible, understanding that his work had become part of automotive history. But history was still being written. In 1985, Carlos developed his most radical engine yet, a twin-plug head that put 2 spark plugs in each cylinder. The design improved combustion efficiency and allowed even wilder cam profiles. Combined with electronic fuel injection and a dry sump oil system, the engine produced 250 horsepower reliably. It was the culmination of 17 years of development. The engine powered a streamlined Beetle, to 165 miles per hour at the Bonneville Salt Flats, setting a class record that stood for years. Carlos didn't attend the record run. He was in his shop, building another engine, still pushing boundaries. Speed records were just numbers. What mattered was the constant improvement, the never-ending quest to extract more from less. By the late 80s, Carlos was semi-retired, building only a few engines a year for special projects. Miguel ran the day-to-day business, which had evolved into manufacturing performance parts for the global VW community. They sold everything from camshafts to complete engine kits, shipping to 30 countries. The Mexico City racing scene had changed dramatically. Modern cars with computer-controlled engines dominated. The old drag strip where Carlos first proved his engines had been replaced by a shopping center. But vintage racing thrived, and Carlos's engines remained competitive decades after their development. A properly built 2300cc stroker could still embarrass modern cars that relied on technology rather than engineering fundamentals. Carlos often thought about those Volkswagen engineers who'd claimed the flat four couldn't exceed 1800cc. They weren't wrong within their context: mass production, minimal maintenance, maximum reliability. But they'd failed to imagine someone approaching the problem differently. Every engineering limit was based on assumptions. Challenge the assumptions, and the limits moved. He'd proven that innovation didn't require corporate resources or advanced degrees. It required curiosity, persistence, and the willingness to fail. His first 10 engines had problems. The 11th worked. Each failure taught lessons that books couldn't convey. The bearing that seized showed him where the oil passages needed enlarging. The valve that broke revealed the importance of guide clearance. The piston that cracked demonstrated the limits of cast aluminum. Young engineers still visited, wanting to understand how he'd developed solutions that university-trained designers had missed. Carlos always gave the same answer: "I built engines that failed and asked why. Then, I built engines that succeeded and asked why." The difference between those answers is engineering. The principle applied beyond engines. Any system, any design, any established limit could be questioned. The key was understanding the real constraints versus the assumed ones. Volkswagen assumed their engines couldn't handle more displacement because they'd never tried. Carlos tried because no one told him he couldn't. That difference in mindset changed everything. In 1990, at age 55, Carlos built his last complete engine. It was for a customer in Germany, a collector who wanted the ultimate expression of Carlos's work. The engine featured every advancement from 2 decades of development: 2380cc displacement, twin-plug heads, programmable fuel injection, dry sump lubrication, ceramic coatings, titanium valves. It produced 265 horsepower at 8,500 RPM. The German customer flew to Mexico to collect it personally. He owned several Porsches worth millions, but said Carlos's engine was the centerpiece of his collection. It represented something pure, individual creativity triumphing over corporate orthodoxy. In an age of computer-designed engines built by robots, it was entirely handcrafted by someone who understood every component's purpose. Carlos continued consulting and teaching through the 90s. Universities invited him to lecture, despite his lack of formal credentials. His experience bridged the gap between theoretical engineering and practical application. He could explain complex concepts using simple analogies drawn from decades of hands-on work. One lecture at the National Autonomous University of Mexico drew 300 students. Carlos brought a cutaway engine showing how his modifications worked together. He explained that engineering wasn't about making one big change, but orchestrating dozens of small improvements. The stock engine was like an orchestra playing at half volume. His modifications let each component perform at its potential while maintaining harmony. A student asked what motivated him to keep pushing boundaries when he'd already proven his point. Carlos thought before answering. My father fought in the revolution because he believed Mexico could be more than others claimed. I built engines for the same reason. Every limitation someone accepts becomes a prison for everyone else. Break one limitation, and others see it's possible. That's how progress happens. One person refusing to accept what everyone knows is true. The legacy was evident in the Mexican racing scene. A generation of engine builders had learned from Carlos's work. Mexico became known for innovative performance modifications, especially for air-cooled engines. Shops in Mexico City could build engines that matched or exceeded anything from Germany or America, often at a fraction of the cost. But the influence went beyond racing. Carlos had demonstrated that innovation could come from anywhere. You didn't need Stuttgart's resources or Detroit's infrastructure. You needed understanding, creativity, and the courage to challenge conventional wisdom. His stroker kits had democratized performance, letting ordinary people build extraordinary engines. By 2000, Carlos was fully retired, though he kept a small workshop at home where he restored vintage engines for friends. Miguel had expanded the business internationally with distributors in Europe and Asia. The company employed 50 people and generated millions in revenue annually. But it remained family-owned, committed to the principles Carlos established: quality over quantity, innovation over imitation, knowledge over secrecy. Car shows invited Carlos as a guest of honor, displaying his historic engines alongside modern supercars. Young enthusiasts who weren't born when he built his first stroker engine sought his autograph on air-cooled cylinder heads. He found it amusing. He was just a mechanic who'd refused to accept limitations. The technical details of his work were documented in books and magazines, studied in engineering courses, replicated in shops worldwide. But Carlos knew the real lesson wasn't about bore sizes or cam profiles. It was about questioning authority, testing boundaries, learning from failure. Those principles applied whether you were building engines or building lives. In 2003, Volkswagen officially ended Beetle production in Mexico, the last country still manufacturing the original design. Carlos attended the ceremony at the Puebla plant, invited as an honored guest. Executives gave speeches about the Beetle's legacy: reliable transportation for millions, symbol of countercultural rebellion, icon of automotive history. No one mentioned that Carlos had proven their engineering assumptions wrong, though several engineers privately acknowledged his contributions. After the ceremony, Carlos walked through the production line one last time. These engines, essentially unchanged since his modifications in 1968, could still accept his stroker kits. Workers recognized him, some asking to shake hands with the man who'd made Beetles fast. He spent hours talking with them, sharing stories of racing victories and engineering breakthroughs. One young engineer asked if he regretted not working for Volkswagen when they'd offered him the job in 1968. "No," Carlos replied. "Inside the company, I would have been limited by policy and politics. Outside, I was limited only by physics. That freedom was worth more than any salary." The engineer nodded but looked uncertain. He'd been trained to work within systems, not challenge them. Carlos understood. Not everyone could take the risks he'd taken. He'd been young, hungry, with nothing to lose. Failure would have meant returning to fixing stock engines for taxi drivers. For someone with a family, mortgage, and career, the stakes were different. But innovation required risk-takers. Every advancement in human knowledge came from someone willing to challenge what everyone knew was true. The Wright brothers were bicycle mechanics who thought they could fly. Thomas Edison had 3 months of formal education. Carlos was just a mechanic who thought German engineers were too conservative. The comparison might seem grandiose, but the principle was identical. Progress happened when outsiders questioned insiders' assumptions. The insiders knew too much about why things couldn't be done. The outsiders didn't know enough to be discouraged. That ignorance, combined with determination, changed the world one small innovation at a time. Carlos's health declined in the mid-2000s. Decades of breathing exhaust fumes and handling solvents had damaged his lungs. Doctors recommended he avoid the shop, but he couldn't resist. The smell of oil and metal was home. The sound of an engine coming to life was music. Building things with his hands gave life meaning. Miguel managed the business, but still consulted Carlos on difficult problems. A customer wanted an engine for vintage racing with modern reliability. Carlos sketched solutions from his bed, his hands still steady despite everything else failing. The resulting engine won championships on 3 continents. In 2008, 40 years after building his first stroker engine, Carlos gave his final interview. The journalist asked what he considered his greatest achievement. Carlos thought about racing victories, speed records, technical innovations. But his answer was different. I proved that anyone, anywhere can challenge what experts say is impossible. That's not just about engines, it's about life. Every person who believes they can do something others say they can't. That's my achievement. He passed away 6 months later, his funeral attended by hundreds from the racing community. Drivers, mechanics, engineers, and enthusiasts came to honor the man who'd made the impossible possible. His engines had powered their dreams, their victories, their businesses, but more than that, he'd shown them that expertise wasn't confined to corporate laboratories or university departments. Miguel inherited not just the business, but the philosophy. He continued developing new modifications, pushing boundaries just as Carlos had. The company evolved with technology, computer modeling, 3D printing, advanced materials. But the core principle remained: question everything, test everything, prove everything. The stroker kits Carlos developed in 1968 were still being sold 40 years later, refined but fundamentally unchanged. Enthusiasts building vintage racers wanted authentic period modifications. Carlos's designs had become the gold standard, copied but never equaled. The imitators could replicate the specifications but not the understanding behind them. Museums displayed his engines as examples of innovative engineering. The Smithsonian requested one for their transportation collection. The Porsche Museum featured his modifications in an exhibit about air-cooled engine development. Academic papers analyzed his solutions to thermal management and mechanical stress. But the real monuments to Carlos's work were the thousands of engines still running worldwide. In California, a grandfather taught his granddaughter to rebuild a 2300cc stroker, passing on knowledge that originated in a Mexico City garage. In Japan, a collector drove a Beetle with Carlos's engine to car shows, its distinctive exhaust note announcing its heritage. In Germany, birthplace of the Beetle, enthusiasts built engines using plans Carlos had published decades earlier. The racing continued too. Vintage racing series worldwide featured classes specifically for modified Beetles. Carlos's engines dominated these events, their distinctive sound, angry, purposeful, mechanical, distinguishing them from modern engines that sounded synthesized and artificial. Young racers discovered that a properly built stroker engine could still embarrass modern technology. The influence extended beyond Volkswagens. The principles Carlos developed, systematic improvement, thermal management, harmonized modifications, applied to any engine. Builders of Porsche, Corvair, and even motorcycle engines studied his work. The specific modifications were less important than the methodology. Understand the system, identify constraints, address them systematically, test relentlessly. Engineering schools used Carlos's story as a case study in innovation. How did one mechanic without formal training out-engineer an entire corporation? The answer involved more than technical skill. It required the confidence to challenge authority, the persistence to overcome failure, the humility to learn from mistakes, and the generosity to share knowledge. Some criticized Carlos for making Beetles too fast, arguing he'd corrupted their humble purpose. but he'd actually honored their design by revealing its potential. Ferdinand Porsche had created a brilliant engine architecture in 1938. Volkswagen had used perhaps 30% of its capability. Carlos showed what the other 70% could do. The democratization of performance was his greatest contribution. Before Carlos, making a car fast required either buying expensive machinery or paying specialists. His kits and instructions let ordinary mechanics build extraordinary engines. Performance became accessible to anyone willing to learn and work. That accessibility threatened established hierarchies in racing and engineering, which was precisely the point. Modern engine technology had moved far beyond air-cooled simplicity. Computers controlled every aspect of combustion. Emissions regulations dictated design. Efficiency mattered more than power. But enthusiasts still built stroker engines, not for their absolute performance, but for what they represented. Individual creativity triumphing over corporate conservatism. The knowledge Carlos documented would outlive any specific engine. Future generations might not care about Beetles or air cooling or carburetors, but they'd face their own limitations, their own experts claiming impossibility. Carlos's example would remind them that expertise often meant knowing why something couldn't be done, while innovation meant not knowing enough to be stopped. His notebooks, donated to the Universidad Nacional Autónoma de Mexico, contained more than just specifications. They documented a way of thinking, a methodology for breaking barriers. Students studying them learned that engineering wasn't about following formulas, but understanding principles. Every rule had exceptions, every limit had conditions. Challenge the conditions, and the limits moved. The Mexico City shop where Carlos built his first engines was demolished for apartments, but a plaque marked the spot. Here, Carlos Gonzalez proved that innovation has no borders, no degrees, no limits except imagination and determination. Tour groups of engineering students stopped there, trying to understand how world-changing work had happened in such an ordinary place. That ordinariness was the point. Innovation didn't require special facilities or extraordinary resources. It required someone willing to ask, "What if?" and then find out. Carlos had asked, "What if Volkswagen's engineers were wrong?" The answer had changed not just engine building, but people's understanding of what was possible. The last engines built to Carlos's specifications would probably run until the 2050s, maintained by enthusiasts who valued mechanical simplicity over electronic complexity. By then, internal combustion might be obsolete, replaced by electric motors or technologies not yet invented. But the principles Carlos demonstrated would remain relevant: challenge assumptions, test boundaries, share knowledge, democratize innovation. His legacy lived not in metal and oil, but in minds freed from artificial limitations. Every person who'd learned from his work carried forward the belief that expertise wasn't exclusive to institutions. Knowledge belonged to anyone willing to pursue it. Innovation came from unexpected places. One person with determination could change what everyone knew was true. The racing victories were forgotten by most. The speed records were eventually broken. The technical innovations were superseded by new technology. But the example endured. A mechanic from Mexico City who'd looked at German engineering and said, "I can do better," and then proved it over and over until even the Germans agreed. That was Carlos Gonzalez's real victory, not the horsepower or the quarter-mile times or the racing trophies. He'd proven that limitations were decisions, not laws. That innovation was democratic, not institutional. That anyone, anywhere, could change what everyone knew was impossible. The engines were just the demonstration. The lesson was universal. Thanks for joining us on this journey through one of history's incredible survival stories. If you found it compelling, give it a like and share it with someone who appreciates these tales of courage. And don't forget to subscribe for more.